Hi, welcome to section 12.1, notes on tangent lines. The first thing here is the tangent to a circle. So that is a line that intersects intersects a circle at exactly one point. And you can see in the picture to the right here that we have a circle, we have a line, and the line is just skimming by the circle and touching it at one point P. So that line L, so where it says example here, I can say line L is my tangent to the circle because it is the line that skims by the circle and just touches it at one point. And I think I want to make that a capital L since that's what it looks like in the picture. Okay, the point of tangency is the point where a circle and tangent line intersect. So this would be point. And in this particular picture, point P is the point of tangency. Okay, that's where line L touches a point on the circle. All right, the theorem that we have that goes along with this says if a line is tangent to a circle, then the line is perpendicular to the radius at the point of tangency. So here it says if line AB is tangent to circle O at P, then line AB is perpendicular to segment OP. So we can see in this picture, OP is our radius. We can see we've got line AB as our tangent line that skims by the circle and touches it at one point. And this is saying a tangent line is also always going to be perpendicular to the radius. And that's by showing that right angle. So anytime you see a tangent line, that means you can add a right angle to your picture there, and that can help you solve other things. And obviously, if it's perpendicular to a radius, it's also going to be perpendicular to a diameter. All right, so some different problems using that information. If we look at examples 1 through 4, you can see there's a tangent line in all of these pictures. You can see some right angles in some of the pictures, and in some cases you don't see the right angle, but you could add the right angles there based on there being a line of tangency. The directions don't say it this time. Usually it says something, any line that appears to be a point of tangent line is a tangent line. It doesn't say it here, but I think because it just talks about it at the top of the page is why. So if we look at example 1, there's actually two lines of tangency here. LM is a tangent line, and it is a tangent line with radius OL. So I know that I can add a right angle symbol here. And ON is a tangent line, and it is perpendicular then to MN is a tangent line, so it's perpendicular to ON, which is the radius. So I can add a right angle symbol here as well. Okay, and then yes, usually the tangent lines kind of skim by the circle and keep going. Sometimes they don't, but you can still see that that is a tangent line, or at least a part of one. All right, there's two different ways I can think to solve this one. One way would be to realize that OLMN is a quadrilateral, and if you think about how many degrees a quadrilateral adds up to, then hopefully remembering 360. Just like all the angles of a triangle always add up to 180, all the angles of a quadrilateral add up to 360. So one way to do this problem would be to say x plus 90 plus 117 plus 90 is equal to 360. And if I solve for that, if I add up my 90 plus 117, I get 297. And if I go and subtract 297 from both sides, then I get 63. As my number of degrees there. Another way to do it, sometimes people just forget that all the angles of a quadrilateral add up to 360, but they can remember that all the angles of a triangle add up to 180. So some people would half that. A quadrilateral always makes two triangles, two congruent triangles. And in this case, if I draw just half of this figure, I've got a right angle. I know that this angle is 117. Oh, no, it's not. Just kidding. It was 117, but we just halved it. So if I did 117, it's not working very well. 117 divided by 2 is 58.5. Okay, so this angle is 58.5. And then this angle, in that case, I'll call it Y, I guess. I don't want to use X from the picture. I'll use Y. So someone else might say Y plus 58.5 plus 90 is equal to 180 instead of 360, because they can remember that. They solve and get Y is equal to 31.5. And then they realize that, okay, X in the picture is actually double what Y is. And so then they get their 63 that way. Okay, so either way, just two different ways to do the same. I'll put an or right here. Two different ways to do the same thing. On number 2, we see DE is our tangent to the radius OD, or to that whole diameter. Remember, the diameter goes all the way across the circle. So if I put my right angle symbol there, again, I see a right triangle. I know two angles. I want to find the third angle. So I can say 90 plus 38 plus X equals the 180. And if I solve for X there, I end up with 52 degrees. That one wasn't too bad. Okay, if we go down here to number 3, one like this gets a little more involved. We get to bring a little more algebra in. We can see here that X is the radius. And even if they didn't tell me that both of these were X and they told me one of them was X, we should be able to figure that out, because obviously a radius, no matter where I put it from the center out to the edge of the circle, is going to be the same length. So, I know this is X and I know that is X because they're both the radius. But it's also showing me that this piece out here from the circle out to A is 8. And then obviously AB is 12, the actual tangent. So because it's a right triangle, I can use the Pythagorean theorem. Okay, but when I plug in for that, think of what the hypotenuse of this right triangle is. It's AC, and if I try to represent what AC is, it is X plus 8, not 8X, so be careful about that. So when I go and plug in, my legs are X squared plus 12 squared is equal to, I want to put that in parentheses, X plus 8 squared. So just be careful about that little detail. When I go and start working it out, I've got X squared plus 144 is equal to, now be careful here. A lot of times people will just say X squared plus 64. Don't do that. So you can go ahead and write your X plus 8 times X plus 8. I think is the safer way to do it. And usually when people see those parentheses, they know what to do. But if they don't write this step, they generally write X squared plus 64, and then it doesn't work out right. So once I do that, I need to go ahead and FOIL over here is what most people learn this as. Some people learn it just as multiplying two binomials, or FOIL, first, outside, inside, last, where I'm going to multiply these two terms. X times X gives you X squared. X times 8 is 8X. 8 times X is 8X. And 8 times 8 is 64. So don't forget your when you FOIL or multiply two binomials, you end up with 4 terms, but generally these 2 terms in the middle are going to end up being the same, and you can combine those together. So then we've got x squared plus 144 equals x squared plus 8x plus 64. Okay, from there, if I go ahead and try to subtract x squared from both sides, you might think when you see that x squared, oh no, I'm going to have to factor and that kind of thing. But when you try to subtract x squared from both sides, then the nice thing is they go away, so you don't have to deal with them anymore in this particular case. So I end up with 144 is equal to 8x plus 64. If I go and subtract 64 from both sides, I end up with 8x is oh no, I made a mistake. I'm going to fix it. A minute ago when I said 8x plus 8x, I should have written 16x. I'm not too far in. I'm going to fix it. Sorry about that. Okay, I know if you're in the room with me, you would have told me. So hopefully you wrote the right thing. And so that 8x plus 8x is 16x. And then now if I go ahead and solve from there, if I subtract 64 from both sides, then I end up with 80 is equal to 16x. And when I go and divide by 16 on both sides, I get x is equal to 5. There we go. All right, you could always check your answer by taking that 5, plugging it back in your picture, and if you plug those numbers into the Pythagorean theorem, it should give you a true statement if it's a right triangle. And this particular problem, just pay attention to what the question is asking for. It's just asking you in this case for x, so we're done. Sometimes they might ask you to plug back in and find another length. Okay, number 4 is basically the same problem, just different numbers. So I would recommend there trying this one on your own. Pause the video, try it on your own, and then you can come back and see if you got the same thing I did. But I will go ahead and work it out for now. So hopefully you've tried it on your own. And in this case, we're going to have x squared plus 8 squared, keeps kind of skipping here, is equal to x plus 6 squared. So again, same idea, x squared plus 64 is equal to x plus 6 times x plus 6. And so x squared plus 64 is equal to x squared plus 6x plus 6x plus 36. So x squared plus 64 is equal to x squared plus 12x plus 36. So in this particular case, I could go ahead and subtract my x squared from both sides. So once I do that, I'm left with 64 is equal to 64 is equal to 12x plus 36. And then if I go and subtract 36 from both sides, then I get 28 is equal to 12x. And when I go and divide by 12 on both sides, I end up with 28 over 12, which that reduces down. If I go and divide 4 into both the numerator and denominator, I end up with 7/3. Okay, if you want to write that as 2 1/3 or 2.3 repeating, that would be fine as well, since the directions don't specify how to leave your answer. Those would be fine as well. Okay, so hopefully you tried that one as some practice. And then on example 5, it says, is segment ML tangent to circle in at point L. So here it is asking if this is a tangent line. If it is a tangent line, we know that this would be a right angle. So to know for sure if that's a right angle, I could plug these numbers into the Pythagorean theorem and see if it gives me a true statement. If it gives me a true statement, it's definitely a right triangle, and therefore that's definitely a right angle, and therefore ML would be a tangent line. So we're they're not telling us it's a tangent line. They're not telling us there's a right angle there. They're asking us if there is one. In this particular case, sometimes it's hard to tell, but in this case, they're telling us that this whole length is 25. And so if I go ahead and plug these numbers into the Pythagorean theorem, again, pay attention. Where my right angle would be means that 7 and 24 would be my legs. So I've got 7 squared plus 24 squared equals 25 squared. Okay, why this isn't working very well. Well, I think I'm getting it fixed. It's so dirty or something. Okay, so if I go ahead and work that out, this is going to work better now. All right, 7 squared is 49, plus 24 squared is 576, and that's equal to 25 squared, which is 625. From there, if I go and combine these together, I get 625 is equal to 625. So because it equaled out on both sides, I know that it is a right triangle. And so I also know that then ML is tangent to circle in at L. All right, here we go. Next page. If you look at this picture, it says the observation deck is 0.3 kilometers above ground level. How far is the observation deck to the horizon? To the nearest kilometer, and the Earth's radius is about 6,400 kilometers. So I think it is very helpful on one like this to draw a picture. So we've got a circle, we've got our Earth, and in this particular case, here's my center, and my radius goes from here to here. My picture, probably going to end up going over the words here, but my tangent line Okay, so what this picture is representing is the fact that, add a little more to my picture. This would be my observation deck, right? Here, I'm just going to draw. Here's my observation deck that I just drew in red. Okay, and so if you think about being at the top of this observation deck, if you look out from the observation deck to the horizon, this is going to be the horizon over here. That's where the Earth starts curving and you don't see the rest of it. So in this particular question, it says the observation deck is 0.3 kilometers above ground level. So that's what this length is representing. From here to here is our 0.3. Okay, and then it says that the Earth's radius is 6,400. So I know from here to here is 6,400. And I know from here to here is 6,400. Okay, the radius is in both cases. And they want to know how far the observation deck is to the horizon. And so that length from here to here is my X that I'm trying to find. And this 0.3 is not looking so hot over here. Let's try and fix that. Okay, so from here, then Again, from the radius skimming by the circle, this should be our right angle here. It might not be drawn perfectly to scale, but it's the same type problem we just saw. We've just got, more numbers that we're dealing with here. So in this particular case, I can say x squared I'm using my Pythagorean theorem again, each side of my right angle. So I've got my x squared plus 6,400 squared is equal to, if I add up the whole hypotenuse that's across the right angle here, then 6,400 plus 0.3 is 6,400.3. And I can square that. All right, when I do that, I am going to get some rather large numbers. I get 4096 with 4 zeros after it. When I square the other side, I get 4096, and then I get 3840.09. Okay, if I'm trying to get x squared by itself, then when I subtract 4096.0000 from both sides, then I end up with 3840.09. And then when I take the square root of both sides, I am left with, when it says to the nearest kilometer, I'm left with 62 kilometers. Okay, is my length from my observation deck to the horizon. Again, it may not be drawn exactly to scale when you're looking at this, but that's the idea of it. Okay, from there, it says if two tangent segments to a circle share a common endpoint outside the circle, then the two segments are congruent to each other. So all that is saying is that if BA and BC are both tangent lines coming from the same point outside the circle, then the measure BA must be congruent to the measure of BC. Okay, so we can use that down here in these other pictures, even though they look a little different. It's just that is happening multiple times in these pictures. So I can see, again, usually the directions would say something about if any line appears to be tangent, it is tangent. So if AD and AF are tangent lines coming from the same point A, I know these pieces are congruent. So if AD is 10, AF has to be 10. If FC and CE are tangent lines coming from the same point outside the circle, then they have to be congruent. I'll give those 2 marks. So if one's 8, the other is 8. And over here, if DB is 15, then EB has to be 15. So if it asks for the perimeter, which is the distance all the way around that triangle, I'm just going to add up 10 plus 10 plus 8 plus 8 plus 15 plus 15. That gets me all the way around the circle. That is my perimeter. So I know if I kind of simplify that, 10 plus 10 is 20, 8 plus 8 is 16, 15 plus 15 is 30. And then if I go and get that added together, I know that perimeter is 66 centimeters. Oops. That backwards. Okay, so 66 centimeters there. So those really aren't too bad if you know that one little rule. And same idea here. This one, though, it's giving me the perimeter and wanting me to find the length of QY. So in this particular case, I know that if this piece is 15, this piece is 15. I know that if this piece is 17, this piece is 17. But my problem over here is QY, I don't know. But I do know these two pieces are congruent to each other. So I do know that this piece, I can call it X. And if that's X, that length is X. Okay, so now if I set up an equation, I know that the perimeter is equal to X plus 17 plus 17 plus 15 plus 15. And again, I know the perimeter, so I'm going to go and substitute 88 in. X plus X, I know is 2X. And now if I add up 17 plus 17 plus 15 plus 15, I get 64. If I go and subtract 64 from both sides, I get 24. If I go and divide by 2 on both sides, I end up with 12. Okay, and that's what it's asking for there. I guess I could actually come back and say QY is equal to 12. Since that's specifically what the question is asking. And, oh, it actually says QY. Can't make mistakes here. Okay, there we go. All right, so that's the end of notes 12.1. Just let me know if you have any questions.